Alright, so the next thing to get into is electricity. I know a lot of you have experience with programming, coding, computer science, hopefully in some way, but you might not have experience with electricity. I know I didn't until I even came to college, and most of it I had to teach myself, but it's also really not that complicated, so I think it's something that can be introduced earlier on, and it makes more sense as you're just around it more. So, to get in, first of all, electricity has voltage and current. And this is probably one of the most helpful things for knowing what electricity is. It's going to help you in your physics class in high school if you take that. They'll definitely talk about this sort of stuff. So you can think of voltage as the amount of pressure being put on electricity, and current is kind of the amount that's being let out, right? So for a similar analogy for water, I would think of a lake as high quantity, low pressure. So that's high current, low voltage, right? You just got a lot going on, but it's not moving too much. There's not too much happening. Low quantity, low pressure is like a puddle, just a little sample of water. This is low current, low voltage. When you increase the pressure, but you keep the quantity low, you have something like the squirt gun. And then finally, high pressure, high quantity. This is like having a high current and a high voltage, and a fire hose can do a lot of damage, and electricity with a lot of current and a lot of voltage, both of those things can also do a lot of damage, right? So that's a big safety hazard, especially wall outlets. I would stay away from wall outlets. There's no reason you should be using them. You should not go near them unless you are a trained electrician, because the amount of things that can go wrong is a really long list, right? But it's also important to understand that having high current or high voltage alone won't necessarily hurt you. If you've had a static shock, you like rub your socks on the carpet and you touch a door handle, that's like, I'm pretty sure it's millions of volts or something like that, but the current is just so small that it doesn't do anything to you. So interesting, important to understand when you're debugging an issue, because the issues that'll come up with too much or too little current are going to be different from the issues having too much or too little voltage. And if we look at the relationship between current, voltage, and resistance, resistance is changing generally the amount of current or voltage that is going to be in your circuit. So hopefully we've all seen a circuit before, something like a battery. You have your positive side, you have your negative side. For something like a AA battery is usually 1.5 volts, which is like the energy level it's at, it's the pressure. And then the current that comes out of the battery changes depending on what is using it. So if you just connect both ends of the battery with a wire, wires are built to have basically no resistance. So if the voltage is 1.5 and this R number is very close to 0, the current is going to be huge, and it's going to get very hot, and it's going to damage the battery, and the battery might explode, which is why we do not just connect two ends of the battery. For any circuit you make, you always want to make sure that there's at least some resistance, because otherwise it's probably just going to cause damage to something. And if you have something like a light or something else that requires a large amount of current and the battery can't supply that, it won't turn on, or there'll be power failures with it, which is kind of an important thing to understand when you're debugging. So to control the voltage or current, generally it's going to be current, because you're going to keep the voltage the same, right? With one battery, the voltage is always going to be 1.5. And so if I have, a 1 ohm resistor, that's the unit of resistance, then my current is going to be 1.5 amps, which you don't need to know the exact math right now, but just that is how these numbers are picked for resistors. Like when someone tells you to get a resistor of a certain kind, and we'll go over what that is later, it's to control the current, right? So that you're not putting too much current through something. Because if you have a circuit like this and you don't have the proper amount of current, right? If you put too much current with it and you have a light, it can blow the light out. And, for something like an LED, you got to be careful with that. If you just hook up two batteries, that's 3 volts, right? Because it's 1.5 plus 1.5 to an LED. That's generally going to be too much current, and it's just going to pop it, which obviously you don't want to be doing. All right, so the other thing that's important is parallel versus in series. I forget what this is all the time, and I have to re-Google it, so I'm introducing it now, but just know this is probably something you're going to have to Google later. There's a million awesome explanations of this, but you have volts here, an ampere, which is current. So for a battery, something that supplies electricity, if you connect the positive and terminal from one to the negative terminal the next, right? You kind of daisy chain them like this. It steps up the voltage. So each of these batteries is 12 volts. There's 4 of them. So 4 times 8, you get 48 volts, right? Makes sense. So if you need a certain amount of voltage or current, you can do these practices to control it. And also, if you need to set up a circuit in a certain way, then you need to understand what sort of battery to give it, such that it can properly fill the needs of your circuit. So the other way you can do it is in parallel, which is all of the negative terminals are attached and all of the positive terminals are attached. So this increases the amount of current, right? 10 amperes times 4, 40 amperes.